Hello, welcome to the video. Today we're going to be looking at lesson 1.6 where we're going to be describing pairs of angles. So in this lesson we're going to figure out how you can describe angle pair relationships and use these descriptions to help you find angle measures. So to start with, let's look at a few examples. So off the bat, we're going to be looking at complementary and supplementary angles. I believe this should be review, but we'll look at it for a bit. Anything that is a complementary angle is any two angles where their sum is equal to 90 degrees. Now they can be angles that are connected by a common endpoint, or they can be two separate angles altogether. They just have to equal 90. Same thing goes for supplementary. The only difference is these two angles are going to be sums are going to be 180 degrees. Okay, it could be together like they are in angles 3 and 4, or angle C and angle D where they're separated. As long as they add up to 180, they are supplementary. This angle relationship does need a specific pairing of vertexes. So adjacent angles are, they say they are complementary angles and supplementary angles that can be adjacent angles or non-adjacent angles. It says adjacent angles are two angles that share a common vertex and side. So if you look here, here's our common side, here's our common vertex. We can say that they are adjacent angles, angles 5 and angle 6. So you have to ask those two questions. Does it have a common side? Does it have a common vertex? If you can answer yes to both of those questions, they are adjacent. Angle 7 and angle 8 are non-adjacent angles because do they have a common side? No. Do they have a common vertex? No, actually, so there's no for both of them. Has to be yes for both things for it to be adjacent. All right, so in this figure it says name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So I look here, I see I got the 37 degrees and 53. That gives me 90. So I can say for my complementary, I could say angle BAC and angle RST are complementary because they add up to 90 degrees. For supplementary, I can look at, so I got what, 127 plus 53, which is 180. So I can say that angle CAD and angle RST equals 180 degrees. So I can say that those are supplementary. And then the final one is they want you to find a pair of adjacent angles. So adjacent angles here would be, okay, do we have a common side? Looks like I have a common side here with AC. Do we have a common vertex with point A? I can say that angle BAC and angle CAD are adjacent angles because it fits those parameters. Here it says that angle 1 is a complement of angle 2. Measurement of angle 1 is 62 degrees, fine too. So it says it's complement. That means when they sum up, it's 90 degrees. So basically, I'm going to say that it's 62 plus whatever the measurement of angle 2 equals 90. To find that measurement, all we got to do is take 90 and subtract it by 62, which means that angle 2 equals 28 degrees. When you have an example like this where 3 and 4, they say are supplementary, supplementary means that they add up to 180. They're telling you that angle 4 is 47, find 3. So you got angle 3 plus 47 equals 180. You just take the 180 subtracted by 47. I get angle 3 equals 133 degrees. In this situation here, it says, we got this diagram. It says name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. All right, so complementary angles here, I can say, let's see what adds up. So what, we got what, 49 plus 41, is that 90? So I could say that angle FGK and angle GKL are complementary. So for my supplementary, let's see what 41 plus 131 is. That's 72, 131 plus 49. Oh, sweet, we got 180. So I can say that angle HGK and angle GKL, those are supplementary. My adjacents, again, find your common side here. They share a point right there, so I can say that angle FGK and angle HGK are adjacent. Question 2 here asks, I'm just going to erase some things on this diagram so we can see. KGH and LKG are adjacent angles. Or are they? So we have K, K, G, H, and L, K, G. Are they adjacent angles? The answer is no. Because, yeah, they do share a common side, but they don't share a common vertex. So like this vertex is G, this vertex is K. It doesn't work that way. And they're saying is R, F, FGK, and FGH. Are they adjacent angles? The answer is no, because yes, they have a common vertex, they don't have a common side. Questions 3 and 4 are like the examples we had on the previous page. Again, I encourage you to give them a try, but if you are having questions, please comment down below. Here in this situation, it says, when viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. Find the measurement of BCE and ECD. So BCE is right here, and ECD is over here. So they're telling you it's supplementary, so it's 180. Great. So we got to find those individual angles. So it's going to be what? 4x plus 8 plus x plus 2 because of that angle addition postulate we can use, and it says it's 180. Combine like terms, 5x plus 10 is equal to 180. Subtract 10 from both sides, 5x is equal to 170. 170 divided by 5 is 34. Now that's not the answer, it just helps us find the answer. So angle BCE is going to be equal to, looks like 4 times 34 because you substituted in, which gives you 136, plus 8 is 144. So I'm going to say that this is 144 degrees. Angle ECD is going to be, what, 34 plus 2, which is 36. And just to double check, add them together, should be 180. And it is. A couple more angle relationships that we will see, not just in this lesson, but in lessons in the future. So to get ourselves familiar with it, a linear pair. So a linear pair is anytime you have two adjacent angles that are from opposite rays. So you got your common side, and with that common side, you have your common vertices. But because you got angles 1 and 2, the special thing about them is angles 1 and 2 are supplementary. So when they say something isn't a linear pair and you're trying to look for one angle and you're given another, knowing that linear pair, those angles are supplementary, is going to help you solve them. Next, you're going to look at vertical angles. Vertical angles are two lines that intersect, and that creates four angles. The thing about it is these angle measures are vertical angles. Not only are they vertical angles, but they're also going to be the same angles. So angles 3 and 6 are vertical angles. Whatever those measurements happen to be, they're going to be the same. Angles 4 and 5 are vertical angles. Whatever those measurements are going to be, they're going to be the same. Coincide, you can also make the assumption too, because these are both straight lines, they're going to be supplementary. So you could say like angles 3 and 4 are supplementary, 4 and 6 are supplementary, 5 and 6 are supplementary, and also 3 and 5 are supplementary. So using that linear pair definition can also help you with those vertical angles as well. Here, they want us to identify all the linear pairs and all the vertical angles in the figure. Okay, so let's look at the linear pairs. Linear pairs are anything that can get us to 180 and also is an adjacent angle. So 1 and 4 are a linear pair because they got the straight line, they have the common vertex, they have a common side. And that is the only linear pair, I believe. Yes, because angles 1, 2, and 3, yes, they do add up to 180, but they are not a linear pair. Next, they want us to find all the vertical angles. Vertical angles, in this case, the only ones would be 1 and 5. It's 2 and 4, no. 1 and 3, no. Yep, 1 and 5. So there's just one set of vertical angles as well. In this example, it says two angles form a linear pair. When they give you this information with linear pair, think of 180 degrees. The measurement of one angle is 5 times the measure of the other angle. Find the measure of each angle. So I'm just going to draw out a line and a linear pair. They're saying that one angle is 5 times. So I'm just going to call this one x. I'm going to call this one 5x. So because they're a linear pair, we know that they're supplementary. So I can say that x plus 5x will equal 180 degrees. So I got 6x equals 180. Divide that by 6. X is 30. So find the measure. So this one's going to be 30 degrees. This one is going to be 30 times 5, which is 150 degrees. Last thing that we're going to look at is being able to just kind of interpret some some things dealing with angle measurement and angle relationships and stuff like that. It says there are some things that you can conclude from the diagram and some things you cannot. For example, here are some things that you can conclude from the diagram below. It says here that you can conclude that all points shown are coplanar, which means they're all on the same plane. A, B, C, and C are collinear, which means they're on the same line. Line AC, line BD, and line BE intersect at point B. Uh, Angle DBE and angle EBC are adjacent, and ABC is straight angle, and point E is the interior of angle DBC. Are there other things that you can conclude? Maybe. But here's the thing is what they're trying to say is you can only conclude things that are shown to you. Like, is DBC a right angle? As right now, we don't know. We can't conclude that. So some things that you cannot conclude is they're saying that AB is congruent to BC. AB congruent to BC. Could it be? Sure, it could be, but they don't tell you that. So a lot of things that we're going to get into further in other chapters is, maybe we have to prove those things, but you can't make assumptions. The problem is you just can't make assumptions. To make such conclusions, the following information must be given. So like you have to have hash marks, you have to have that right angle symbol, you have to have, you know, the hash marks for the angles and stuff like that. So again, you just have to make those kinds of observations before you can create those conclusions. And that is being able to describe pairs of angles. I hope this helps. Until next time.